Welcome to part 3 of my NumPy course. In this tutorial, we will learn different methods to create a NumPy array. As always, the very first thing we have to do is to import the library. We do that by saying import NumPy as np. Remember that every time you want to inspect any Python object or a library, you can always use this function called dir. In this case, I'm going to print dir, and what I want to inspect is the entire library. Then I give as argument np. If I execute this line, I get all the methods and attributes that NumPy library contains. What if I want to have additional information about one of those methods or attributes? For instance, let's take here min or minimum or max or whatever. If I want to have more information about it, then I can just type np. So that's the library, dot. So the dot is basically the way we can access all the methods and attributes from this library. Then what we want to have a bit more information. Let's use, for instance, sum. Now I just give the question mark and execute this line. What we get is the docstring, and here it says the sum method returns the sum of array elements over a given axis. As you go forward in this series, we will experiment more and more of NumPy methods. Now let's dive into the main topic of the video. NumPy comes with plenty of built-in methods to create NumPy array. One of the most common ways is to create a NumPy array from a numeric sequence, such as a list or tuple. Let me show you. We can use the array function from NumPy to create 1D array, 2D array, or any dimension array. And to create a one-dimension array, it's quite simple. You just need to define your list or tuple. In this case, I have a list, and then assign this list to a variable called myList. Now, if I want to create a NumPy array, what do I have to do? I just type np, which is NumPy, then dot, and type array. What do I need to provide in this function is the name of my list. If I execute this code, I get first my list, then my NumPy array. For a 2D array, the only thing you need to do, you need to have a nested list, and a nested list is only a list inside another list. Alright, now how to create a 2D array? That's the same. You just type np array, which is our function to convert our list into a NumPy array. Then I give my list. Now, if I execute this code, then we get our two-dimension array. And what this class numpy.nd array is telling us is that this matrix is a NumPy array. Alright, what if you want to create an array with a large number of elements? Typing element by element is no fun at all, right? One could argue that we could use list comprehension. This is correct, we can use it, but if you do that, you'd need at least 2 lines of code. Let me show you. To save some time, I will just paste some code here. In this case, we are generating 20 numbers from 0 to 20, and then I assign this list to a variable called myList. Then I just use the function we just saw called array and convert this list to a NumPy array. If I execute this code, I get my NumPy array from 0 to 20. We just saw that if you want to deal with a very large number of elements and avoid typing element by element, we can use list comprehension. Now I want to show you a much better way to do it. In a single line of code, we're gonna have the same result. And for that, we're gonna be using a NumPy function called arange. Let me show you. Here, I will reproduce what we have done with the list comprehension. And to do that, we just type np, and as argument, I'm gonna give 21. If I run this code, I get the very same NumPy array. I would like to draw your attention in one point here. Before, use the list comprehension solution, we use the range function, and the range is a built-in method from Python. And now we are using the arange function from NumPy, and both of them has one particularity. What is that? Here, I'm giving the number 21. However, my array goes from 0 to 20. It means that this number here, which I give, is excluded. And the same holds true with the arange function. And here I'm also giving 21, and the list goes from 0 to 20. And in both cases, in the range and arange functions, we can give actually start, end, and the interval. For instance, if I here want to start from 1, I just type 1. You see that my array will no longer start from 0, but from 1. And if I want to even give an interval, for instance, if I type 2 here, as our interval is 2, we just get odd numbers. Then our last number is 19. Alright, now our second example. Here I define three variables, start, end, and interval. Then I create my array, use the np arrange function. So start is 1, end is 10, and interval is 2. Now I can print my array. And I'm running it again to reinforce it to you. The start value is included, the end value is excluded, and the interval is basically the step you want to take from the start number. So that's gonna be 1 plus 2 plus 2 plus 2 up to the point we reach the end. And remember, the end is excluded. What if you don't want to give a step size as parameter, but the number of samples between the minimum and the maximum number? For that, we use the linspace function. Let me show you. When calling the linspace function, it is very similar to the arange function. You first give the start number, the end number, and the number of samples. If I just run this code, we get 25 samples from 1 to 5, and notice that now the end number is included. And before, when you use the arange function, the end number was excluded. Okay, but what if you don't specify the number of samples? Let me just delete this number here. You still get a Numpy array, but now you get 50 samples. So by default, if you don't specify any number of samples, you get 50, or you specify it, then you get the desired amount of samples. What if you want to generate arrays with random numbers? Well, luckily NumPy offers the random module, from which we can have access to different functions. For instance, if you want to generate functions between 0 and 1 having the same probability to be chosen, you can use the rand function. But if you want to follow the normal distribution, then you can use the randN function. Now let's check together what this randInt function does. To access the random module, you just need to type np.random. It means that now you have access to all the functions which belongs to this module. And here I want to create a NumPy array with 10 elements from 0 to 5. And as you saw with arange function, here the start number is included, but the end number is excluded. Then let me just change it to parentheses. Alright, and what is cool about this function is that now we can even create 2D arrays. How? I just need to give a tuple and now the number of rows and columns. Let's create a 3x3 matrix. And actually our matrix does not need to be squared. And here we can say, for instance, 4 rows and 3 columns. I'm all the time saying matrix, but in fact it is a 2D array. And 2D arrays start getting very important when you start talking about linear algebra. And for linear algebra, NumPy has also some special methods. In case you want to initialize a NumPy array with zeros, we can use the zeros function. Let me show you. Here, if I want to create a 1D array, I just need to type np.zeros, then the number of elements I want to have in this array, let's say 10. If I execute this code, we get 10 elements and all of them being 0. And what is nice, I can also initialize a 2D array. I'll just comment this line, uncomment the last 3. And now I'm no longer giving an integer, but a shape. And shape here is basically a tuple. So here I could just give a tuple like that, 3 rows and 2 columns. Now we have a 2D array with 3 rows and 2 columns. All right. And just to make it, let's say, a bit nicer, I will just call this variable here. And that's the same. Okay. Similarly, we have this function called ones. And as you can imagine, now we're going to initialize this array with ones. And again, we just choose the number of elements you want to have. In this case, we're going to have 5 elements and all of them being 1. And same as you saw before, we can also create 2D arrays. And now we have 3 lines, 4 columns. But what is happening? We were expecting to have ones, right? But what we can do, if you want to initialize with ones, we can just give the ones function. But if you want to initialize with 2, 3, or any number, you only need to multiply it. Let's initialize all the elements with 5. Then we have a matrix with 3 lines, 4 columns, and all the elements being 5. And you remember from linear algebra this idea about identity matrix? Well, we can also have it in Python. We just need to call the identity function. And the identity matrix is a square matrix. And this is the reason why you only need to give one number. If I just give 2, we then generate an identity matrix of 2 by 2, 2 rows and 2 columns. So far, we have been using NumPy methods to create arrays. But what you can also do, once you have arrays, you can also use arrays methods. And as I showed in the beginning of this video, we can inspect any Python object. Let's now inspect a NumPy array. Here, I just create a NumPy array. I just call the arrange function, so it's going to be from 1 to 9 because again, the last number or the end number of the arrange function is excluded. If I print the dir of this NumPy array, what I get is a list of all the methods and attributes of this array. If you're interested to know all the methods of a NumPy array, you let me know and then I create a video for that. But now, the only method I want to show you is this method called Reshape. Where is it? Reshape, so this one. With this method, we can reshape any NumPy array and create a 2D array. And actually, we can create a 3D array, 4D array, or any D array. Let me show you. I will just hide this result. How? Just double click this gray box here. And what I'm doing here is the following. Let me just delete this line. If not, it's going to be a bit confusing. Let's print our array. Let's say from 1 to 12. Now, if I want to reshape this NumPy array, the only thing I need to do, I just use the dot notation. Now I'm accessing all the methods and attributes of a NumPy array and then type reshape. Okay, but to which shape do I want to have? Let's see, we have 12 elements. Then you can reshape this array with 4 rows and 3 columns. Let me just execute it. And there you are. One thing you need to be careful. How many elements do you have here? We have 12, right? When you multiply the number of rows by the number of columns, it should obviously result in the same number of elements you have in your array. If I now try to reshape that with 16 elements, then it's going to raise an error. It says, okay, I cannot reshape 12 elements into 16. All right, let's do the opposite. 3 rows and 4 columns. And we can also do 6 by 2, right? And the opposite, 2 by 6. And let me show you something else. If I want to transpose this matrix or to have 6 rows and 2 columns, you just need to type dot t. And then there you are. Let's create a 3D array. So how many elements do we have here? We have 12. Let's create 25 or 24. So what we can do, we can have 3 rows, 4 columns. Okay, this will result in 12 elements. Now I want to have one more axis. Then I get my 3D array. If it is a bit hard to understand that it is a 3D array, I can also break down and show you array by array. So what is that? This is my first element, which is my 3 by 4 array, correct? But it has also a second element, which is again a 3 by 4 array. And if I just show them all together, this is now our 3D array. I hope this is clear for you. Lastly, I want to show something which is very nice for NumPy array, and at least I don't see much people using that. When you want to read data from a text file, you can load it and already create a NumPy array. And how to do that? We can use this function called gen from txt. And now what you have to do, you just need to specify the path of the file, or basically where this file is located, and the delimiter. So what is the delimiter? Let me show you one example here. Here I have my text file, correct? And the delimiter is basically what is happening or what exists in between the data. In this case, I have a tab. So, and how does Python interpret a tab is \t. If I run this code, I get now a NumPy array or a NumPy 2D array with all the elements. And what is nice, look at this file. We have a comment here. And you can have as many comments as you want, because when reading this file, NumPy will just ignore it. So then I'll just type comments are ignored. So I just save it, run it again, and there you are. If you look at the file, you see that our file has the first column which belongs to X values and the second column which belongs to Y values. But when I run this code, what I get is just one array. Now, how can I split it? How can I take the first column and say, look, the first column belongs to a variable called x, and the second column belongs to a variable called y. And this will be the topic of our next video. We'll learn the idea of indexing and how to slice a Numpy array, regardless if it's gonna be a 1D, 2D, 3D, or any dimension array. I hope you have learned something different in this video, and see you in the next one. Bye bye.